is to implement linear search. In this experiment we have to implement linear search and binary search. So first we will go with the code for linear search. So this is our code, this is the boilerplate. This I have included to use clock function to get the speed as also as output. So here we have implemented our function linear search. So we traverse through a whole vector till v dot size, and we compare iteratively b of I equal to a. If it is so, it will give I plus 1, that is its position. Since we start from 0, we add plus 1 to it, or else we will do nothing. Otherwise, after the whole iteration, if we don't find, it will return minus 1. So this is our main function. Here we have initialized a vector. Here we are taking n, the number of elements from the user, as the input, and here we are taking input for the array. So till n it will run the one which user will give. This will take the value from the user and it will push to the vector. So okay, so now we will ask enter the element to search. So the user will enter the element to search, and auto start. Auto we have used to automatically guess what is the data type, and start we are start equal to high resolution clock now. So start will start to calculate the time, the function which it will take to implement. So here we are calling linear search. At position, at pause, we are calling linear search. So and afterwards the function is finished, we will stop, we will call stop. So it will stop the clock, and here we will calculate the duration, stop minus start, and this will give us the output in microseconds. And so we will run our code. So increase the font. Okay, so we will give a 5 as element, we will give 1, 2, 3, 4, 5, and the element to search we will give as 3. So okay, you can see that it has given at position 3, and time taken by the function is 59 microsecond. And in case 2 we have to give an element which is not present in the array, so we will give that also. So I will give it as 6, so you can see that it has taken 60 microseconds. So now we will move on to our next question, that is binary search. Our next task is to implement binary search also. So what happens in binary search is it divides the array into two halves every time. So it checks in the other half if you can see that here we are starting from mid. So here we will start starting position, and here we will give ending position and the element to search, also the vector. So here it will start from mid equal to start plus n by 2, and if start is less than equal to end, this is our base case to stop the recursive approach, because start will never surpass end. And if v of mid equal to a, that means our mid element is equal to a, we will return mid plus 1. Okay, so if our a is greater than mid, so we will search in the other half. So our start will get updated to mid plus 1. After the mid, it will start, it will go till end, and it will recursively call this binary search function. So else if our a is less than, we will update the end to mid minus 1, that is before mid, and it will start from start minus 1. So it will recursively call every time, and if not, if start surpasses the end, we will exit. Our recursion will stop and we will return minus 1, that means element is not present. So here we are taking input from the user, here we are initializing a vector, same as linear search. Here we are taking the number of elements, and here we are taking elements for the vector. So here we are initializing start as 0 and end as v dot size, that will it will give the size of the vector. and we will ask the user to enter the element to search. And here we are giving, here this is to calculate the time execution. And at position binary search, we will start with, we will pass vector start position, that is 0, and position, that is without size, and here the element to search. And here we are stopping the clock, and here we are calculating the duration. Also we are giving output as duration dot count. So okay, this all falls in the library chrono. So since we have included bit slash, so it includes all the library. So now we will run our code. Now we will use same as linear search, we will use 3. So okay, so now we will give element which is not present. So we will give 5, 1, 2, 3, 4 and 5, and we will give 6. Okay, so this time depends on our machine and compiler also, so it may vary sometimes. So okay, so this is how binary search works. So this was the